A balloon lifting into the sky. Buoyancy and density. A hot air balloon rests on the ground like a giant folded lantern. Then the burner roars. The fabric swells. The basket begins to lighten. Slowly, with no wings and no propeller, the whole machine rises into the sky, carrying people beneath it. It looks almost magical. But a hot air balloon is not escaping gravity. It is using gravity through a force called buoyancy. Air may feel empty, but it has mass. A column of air above the ground presses downward, and every object in that air has to push some of it aside. When a balloon occupies a large volume, it displaces a large amount of surrounding air. According to Archimedes' principle, the upward buoyant force on the balloon equals the weight of the air it displaces. This principle is often taught with water, but it also works in gases. A boat floats because it displaces heavy water. A balloon can rise because it displaces air that is heavier than the air inside it. The burner heats the air trapped inside the balloon envelope. As the air warms, its molecules move faster and spread farther apart. The same volume now contains fewer air molecules than the cooler air outside. In other words, the air inside the balloon has lower density. The balloon, its basket, its passengers, and the hot air inside still have weight. But if their total weight is less than the weight of the cooler outside air displaced by the balloon, the net force points upward. The balloon rises until lift and weight come back into balance. If the pilot heats the air more, the inside density decreases and the balloon can climb. If the air cools, the inside density increases and the balloon descends. Steering is indirect. Pilots usually change altitude to find winds moving in different directions. Then let the atmosphere carry them. A common misconception is that hot air rises simply because heat itself has an upward force. Heat is not a lifting force. Heating changes density. Lower density in the same gravitational field creates buoyancy because the surrounding cooler air weighs more for the same volume. This is also why helium balloons rise. Helium is less dense than air even without heating. Hydrogen is even lighter, though it is dangerously flammable. Hot air balloons use ordinary air made temporarily lighter by heat, and they need large envelopes because the density difference is modest. The same physical idea appears in ocean floats, submarines, weather balloons, and even the rising columns of warm air that birds and gliders use. In every case, the question is not whether something is heavy in an absolute sense. The question is whether it is lighter than the fluid it pushes aside. A hot air balloon is a quiet lesson in balance. Heat spreads the air inside, density falls, buoyancy wins by a small margin, and a basket lifts from the earth.